Hi guys! So, today we are going to discuss about experiment 6, which is acid-base titration. Okay, so we will have a quiz tomorrow about acid-base titration. So, the objective of the experiment acid-base titration is this. First is to apply the concept of acidimetry and alkalimetry. And the second one is to standardize a sodium hydroxide solution. And the third one is to identify the total acid content of vinegar. Now, let us first go to our first objective. When we are talking about acidimetry, it is a specialized use of acid-base titration in order to determine the concentration of an acidic substance. So, gumagamit ka ng acid-base titration para ma-determine yung concentration ng acid-base substance or acidic substance. When we are talking about alkalimetry, same with acidimetry, it is a specialized use of acid-base titration wherein we use the acid-base titration in order to determine the concentration of the basic substance, basic which is synonymous to alkaline. Okay, so in our acid-base titration, let us first define what is this titration. So titration, acid-base titration is widely employed particularly sa pharmaceutical, sa paggawa ng gamot. So because it is used to determine numerous inorganic, organic, and biological species that have an inherent acidic or basic properties. Okay, so the concept that is behind this acid-base titration is a neutralization reaction. Neutralization reaction between an analyte and a titrant. A titrant can either be a basic titrant or can either be an acidic titrant. In an acid-base titration, or particularly in a neutralization reaction, there is a constant production and consumption of proton. There is a constant production and consumption of proton. Kaya nag-iiba-iba yung ating pH. Kasi nga, may napuproduce na hydrogen ion at may nakukonsume na hydrogen ion. And one of the very most important part of titration is what we call as an indicator. This indicator will then determine the changes in pH. Because of the constant consumption and production of hydrogen ion, hindi natin malalaman kung ano talaga yung pinaka-pH niya. Kaya we need a pH indicator or an indicator in order to determine the pH changes. And up until ma-reach natin yung tinatawag nating equivalence point. Equivalence point is defined as the amount of, or is defined wherein the amount of titrant is chemically equivalent to the amount of analyte in the sample. Meaning, nagkakaroon tayo dito ng neutralization. The concentration of the hydrogen ion and the concentration of the hydroxide ion is equal. Kaya nagkakaroon tayo dito ng neutral solution at the equivalence point. So, ibig sabihin, the amount of our titrant is chemically similar or chemically the same with the amount of our analyte in the sample. So in our experiment, for example, we have this titration setup. Wow. Titration setup. In our experiment, our sodium hydroxide is our titrant. The titrant is known as the sodium hydroxide. Sodium hydroxide, NaOH. The titrant is the sodium hydroxide. Our analyte is the one that is located here in the beaker. It's located here at the Erlenmeyer flask. Erlenmeyer flask. Okay. Ang ating titrant is nandito sa ating burette. Titrant din dito. At nandito naman yung ating analyte. Okay. At nandito naman yung tinatawag nating analyte. Let us remember that titrant are always strong acids and bases. They are always strong acids and bases. So in a titration reaction, kailangan nating malaman yung concentration ng ating titrant para malaman din natin yung concentration ng ating analyte. And we can know the concentration of titrant by the process of standardization. The standardization is a way on how we determine the concentration of our titrant. It can either be using a primary standard or using another solution with known concentration. Let us remember that a primary standard is a reagent that is extremely pure and stable. Some of the characteristics of a primary standard is, yes, it is extremely pure, it is very stable, that's why it has low reactivity, it has low hygroscopy or low hygroscopicity, it has a high molecular weight, and it has no water of hydration and no tendency to become hydrated. Ibig sabihin, those are the characteristics of primary standards. And we can also determine the concentration of the titrant using another solution with known concentration. So in our experiment, we use what we call as a primary standard. The primary standard that we use in our experiment is the KHP, or the potassium hydrogen phthalate, KHC8H8O4. Okay, yeah, that's right. The potassium hydrogen phthalate, or the KHP, is our primary standard. So after determining the concentration of the titrant in our standardization experiment, which is the part B of our experiment, we then determine the total acidic content of the vinegar sample in the part C. So in this type of experiment, we are going to define, or we are going to enumerate the several steps that are used in this experiment. So in the first step of the experiment, or the part A of the experiment, is the preparation of the sodium hydroxide solution. So what we did in the experiment is we weigh roughly 10 grams of sodium hydroxide pellet in a tiered small beaker. The 10 gram of sodium hydroxide pellet, is then dissolved in a distilled water. Pagka-dissolve natin siya sa distilled water, nilagay natin siya sa 500 ml volumetric flask. Nirinse natin yung beaker containing the dissolved sodium hydroxide pellet, nirinse natin siya ng tubig, tapos nilagay natin yung rinsing dun sa volumetric flask. Then we add additional distilled water up until to the marker of the volumetric flask, and then we shake the solution and then label it. So, ang hindi natin ginawa is we did not store the solution in a plastic container. Kasi diretsuhan naman yung paggawa natin or yung paggamit natin sa kanya. And the second part of the experiment is the standardization of the NaOH. So, in the standardization of the NaOH, what we did was we weigh an accurately 1.000 grams of potassium hydrogen phthalate, and then we dissolve it again in a 50 ml distilled water. We mixed it thoroughly, and then we add a 2 drop of phenolphthalein indicator. So, nag-weigh tayo ng 1 gram of kpH, dinisolve natin siya sa 50 ml of distilled water, tapos, nag-add tayo ng 20 or 2 drops of our phenolphthalein indicator. And then we titrated that kpH performing 2 determinations. And then we determine the molar concentration of the NaOH. So, sa standardization natin, ang pinaka-endpoint natin is the determination of the molar concentration. And in the last part is determination of the total acidic content. We then get 10 ml of vinegar. Then we put it into a 100 ml volumetric flask. We then add distilled water up until to the mark of the 100 ml volumetric flask, and then we shake it thoroughly. Okay? Shinake natin siya. Nag-aliquot tayo ng 20 ml coming from the volumetric flask. Then we add an additional 30 ml of distilled water, which is the one that is utilized in the experimentation process. Pagkatapos nating mag-add ng 30 ml ng distilled water dun sa 20 ml na aliquot, nag-titrate tayo up until to 2 determinations hanggang makuha natin yung tinatawag na endpoint. Pagkatapos, kinalculate natin yung total acidic content by the percent composition weight over volume of the acetic acid in the vinegar sample. Okay. Pagkatapos ng ating experimentation process, kailangan nating makuha ang ating ang ating molar concentration ng sodium hydroxide. So, ibig sabihin, nasa part B pa lang tayo ng ating experiment. So, kailangan natin yung mga data na to. Halimbawa, na-fill up mo na siya. So, the weight of KHP, potassium hydrogen thalate for trial 1 is 1.00 gram. The final reading is 32.5 ml. Initial reading is 22.5 at ang volume consumed is, ang kailangan mo lang dito is subtract the initial reading from the final reading. So we have 32.5 minus 22.5, which is equal to 10. So halos 10 ml yung volume consumed ng ating standardization process. And here, in trial 2, we then also repeat the procedures, nakakuha tayo nito. And then, we get a total of 9.9 ml for the volume consumed of NaOH. So, ang kailangan natin dito ay ang molar concentration ng ating sodium hydroxide. Paano nga ba natin kukunin yung ating molar concentration ng sodium hydroxide? Ang kailangan natin is may data dapat tayo ng ating weight ng sodium hydrogen thalate or the KHP natin. Kasi, itatranslate natin tong kanyang weight na to papunta sa molarity ng sodium hydroxide. Papunta sa molarity ng sodium hydroxide standard. Paano? Halimbawa, so we have 1.000 grams of potassium hydrogen thalate, right? So, in this procedure, itatranslate natin siya papunta sa molarity ng sodium hydroxide. So, ang kailangan natin is, the molar mass of the KHP. So, sinabi natin na a primary standard is a reagent that has a very high molecular weight, di ba? So, pagka-solve mo, nakita mo o nalaman mo na ang kanyang molecular weight or ang kanyang molar mass is 204.22 grams of KHP. So, 204.22 grams of KHP in every 1 mole of KHP. In every 1 mole of KHP. So, kailangan natin dito ng tinatawag na molar ratio. Molar ratio. So, ilang mole ng KHP ang ilang mole ng KHP. So, halimbawa, ilang mole ng sodium hydroxide, ano yung pala yung molar ratio, ng sodium hydroxide at KHP. So, malalaman natin siya using our balanced equation. So, this is our balanced equation. So, we have here the sodium hydroxide, the potassium hydrogen thalate forming this compound here. Okay. So, there is 1 mole of sodium hydroxide in every 1 mole of potassium hydrogen thalate. That's why ang kanyang molar ratio is 1:1. So, we have 1 mole of KHP is equal to 1 mole of NaOH. Okay. So, ang endpoint natin dito is dapat makuha natin yung mole ng NaOH. So, ay ka-cancel natin to. Cancel this, cancel this, cancel this, and we will get 4.90 times 10 raised to -3 mole of NaOH. Titigil na ba tayo? Hindi. Ang kailangan nating makuha ay ang molarity. Molarity of NaOH is equal to the mole of NaOH over the liter of solution. Over the liter of solution. So, paano natin makuha yung molarity? So, molarity, meron na tayong mole, which is 4.90 times 10 raised to -3 mole of NaOH. Ano yung liter of solution natin? Ang liter na solution natin, for example, this is for trial 1, nakagamit tayo ng 10 ml ng NaOH solution. So, since ml siya, kailangan natin siyang i-translate or i-convert into liter. So, we have 0.010 liter. 0.010 liter para makuha natin ang 0.49 molar NaOH. Or 0.49 mole per over liter NaOH. That is for trial 1. Gets mo na? Okay. So, i-backward nyo or something para ma-gets nyo. Basta, sa pag-cancellation, dapat ika-cancel mo taas, baba yung pag-cancel para ma-come up natin yung mole ng NaOH. So, okay. For the second trial, halimbawa, you have this data. For the second trial, you have this data. Okay. So, paano natin siya isosolve? Sige nga, i-try nyo kung paano natin siya isosolve. Okay. Now, let's go for the solving. Okay. Ang kailangan natin, or ang data ulit natin is meron tayong 1.00 gram of potassium hydrogen phthalate. So, kailangan natin ng molecular weight, 204.22 grams of KHP in every 1 mole of KHP. A molar ratio coming from the balance equation, we have 1 mole of KHP is equal to 1 mole of NaOH. So, cancel. Makakakuha tayo ng 4.90 times 10 raised to negative 3 mole of NaOH. Okay. So, for the second trial, we will get the molarity. Molarity is equal to the mole of NaOH over the liter of the solution. So, we have here 4.90 times 10 raised to negative 3 mole NaOH over the liter of the solution, which is 9.9 ml, is equal to 0.0099. Okay, 0.0099 liter. At makukuha natin ang molarity na 0.49 molar NaOH or 0.49 mole per liter NaOH. Okay. So, diretsuhan ko na siyang i-convert. Pero kung gusto nyong ml na muna ang gamitin, so ganito lang yon. So, we have a 4.90 times 10 raised to negative 3. Kung gustong ml nyo dito, so we have 9.9 ml. Parang ganito siya. So, 4.90 times 10 raised to negative 3 mole. Tapos, meron kang 9.9 ml dito. So, i-convert mo siya sa liter, di ba? So, we have 1,000 ml para ma-cancel yung ml times 1 liter. So, yun. Ganun lang. Pero pwede mo naman siya i-diretsuhan i-convert eh. Nag-ano ka lang ng 3 decimals. So, 1, 2, 3. Okay? So, magiging answer pa rin natin is pareho lang. Okay. Answer pa rin natin is pareho lang. Gets? Okay. So, nakuha natin ang 0.49 molar NaOH. So, computed molarity is equal to 0.49 molar. For the trial 2, we have 0.49 molar. And the mean molarity is molarity of trial 1 times plus molarity of trial 2 over 2. We have 0.49 pa rin. So, para dun sa nahihirapan sa stoichiometry, ganito ang tinatawag natin na the stoichiometry map. So, okay. So, ang kanina, kinonvert natin ang grams ng KHP papunta sa mole ng NaOH, di ba? Mole ng NaOH. So, ang una muna natin ginawa is the grams of KHP papunta sa mole ng KHP utilizing our molar weight. Grams of KHP papunta sa mole ng KHP, ni-utilize natin ang ating molar weight ng KHP. Pagkatapos natin makuha yung mole ng KHP, ginamit natin yung data na yon para makuha natin yung mole ng NaOH utilizing the molar ratio. So, from mole to mole, ang kailangan natin is molar ratio. Samantalang from grams to mole, ang kailangan natin is molecular weight. So, ganun lang siya. Basta, for example, kailangan mo nang mag-meet sa mole to mole bago mapunta sa, for example, sa iba pang component. Halimbawa, i-convert mo yung grams ng KHP papunta sa grams ng NaOH. Ang magiging stoichiometry map mo yun dyan is the grams of KHP papunta sa mole ng KHP papunta sa mole ng NaOH papunta sa grams ng NaOH. Nakita nyo, palaging nagmo-mole to mole muna bago mapunta dun sa pangalawa or bago mapunta dun sa endpoint na kailangan mo. So, ang ni-utilize natin dito is grams to mole. Ang ni-utilize natin is molar weight. Dito, ang i-utilize natin is molar ratio. Dito, i-utilize naman natin is molar weight. So, ganun lang. Okay, since we are basically done with the part B of our experiment, which is the standardization of our sodium hydroxide solution, kasi diba sabi ko kanina, ang pinaka-endpoint ng ating part B is to determine the concentration of the standard NaOH solution. Now, let's proceed to our part C, which is the determination of the total acid content in commercial vinegar sample. So, naging ganito ang magiging itsura ng data nyo. So, we have here the brand of the sample, we have the Dato Puti vinegar. For the trial 1, the volume of the sample is 10 ml. Then the final reading is ganito. We have the initial reading, final reading, the volume consumed is 2.3. And then for trial 2, ganito lang din. Ang ni-utilize natin na molarity ng NaOH is 0.49. Yun yung average kanina, 'di ba? So, 'di ba ang sabi ko kanina, kailangan mo muna ng molarity ng titrant para malaman mo yung pinaka-molarity ng ating analyte. Kaya nga, nag-standardize muna tayo ng molarity, nag-standardize muna tayo ng NaOH, which is our titrant, para maka-proceed tayo dito sa ating part C. So, ang kinailangan dito sa part C natin is the total acidity in the sample. Ang total acidity in the sample ay minsan nasa percentage siya, minsan nasa percentage, or minsan nasa grams per ml yan. Minsan nasa grams per ml. Halimbawa, ang set na percentage ng FDA sa ating mga suka is 4 grams per 100 ml of acetic acid. 4 grams of acetic acid for 100 ml of vinegar. 4 grams of acetic acid for 100 ml or vinegar, or almost 4% of acetic acid. So ngayon, i-determine natin kung ang ating bang Dato Puti vinegar ay nag-follow or fina-follow niya yung standard na 4 grams of acetic acid or per percent acetic acid, or 4 grams of acetic acid per 100 ml of vinegar. Okay, so the first formula that you are going to learn is on how to determine muna the grams of our acetic acid. Kasi diba sa ating objectives kanina, kailangan nating makuha ang total acetic acid natin in a ano sabi doon? In a percent composition weight over volume or grams per ml. So, kailangan muna natin ng ating grams of acetic acid. Makukuha natin yung grams of acetic acid by utilizing the formula, which is the volume of NaOH, or the volume of the titrant, times the molarity of our NaOH or the molarity of the titrant, times the molar weight of acetic acid, times the equivalence factor. Molar times the equivalence factor, or the F. Okay, so paano yan? Let's now go to our substitution. For example, in our trial 1, na-utilize natin ay 2.3 ml ng ating NaOH. Pero sa volume ng NaOH natin, ang kailangan natin dito is liter. So ita-translate natin or i-convert natin yung ating 2.3 ml of NaOH sa liter, which is 0.0023 liter of NaOH. The molarity of NaOH is 0.49. That is 0.49 molar or mole over liter. Ang molarity naman, or ang molar weight naman ng ating acetic acid is 60.052 grams per mole. 60.052 grams per mole. And then, the equivalence factor. Ang equivalence factor natin is makukuha natin siya sa ating data. Paano natin siya makukuha? Halimbawa, okay, so it is normal in fractional form. So, the numerator of our equivalence factor is the one na kung saan yung total volume ng ating solution pagkatapos natin siyang i-dilute, 'di ba? Sa pagkatapos natin siya i-dilute. 'Di ba sa ating part C, sa isa sa mga procedures ng part C natin is kumuha tayo ng 10 ml na vinegar, inilagay natin siya sa volumetric flask, then dinilute natin siya up to the mark of the 100 ml volumetric flask. So, ang numerator natin is the final volume after dilution, which is 100. Okay? The denominator is the aliquoted volume. yung ginamit mong volume dun mismo sa titration. Diba sa procedures natin, nag-alikot tayo ng 20 ml. So, nag-alikot tayo ng 20 ml. So, dito yung 20. So, ito yung final volume na makikita natin pagkatapos natin ng dilution. Ito naman yung tinatawag natin na aliquoted volume. Okay. So, we have 100 over 20. Okay. So, let's now compute it kung ano ba yung kanya magiging answer. So, we have 0.0023 times 0.49 times 60.052 times 100 over 20. So, we will get 0.3384 grams CH3COOH. Okay. So, sabi dun sa procedures natin or sabi dun sa ating objectives, kailangan nating makuha ang percent or kailangan nating makuha ang total acidity ng ating acetic acid using the percent composition. So, percent composition of mass over volume. Okay. So, the mass of solute over the ml of solution times 100. Okay, so we have a mass of solute of 0.3384 grams CH3COOH. Then, the ml of solution. So, ano yung i-utilize natin na ml? Ang dami-dami natin sinabi dito sa procedures natin. Meron tayong 10 ml na vinegar, tapos dinilute natin siya para maging 100 ml, tapos nag-alikwa tayo ng 20 ml, tapos dinilagyan ulit natin siya ng 30 ml. So, saan sa kanila yung gagamitin natin? Ang gagamitin natin is yung pinaka-pure na vinegar, yung hindi pa diluted. So, ano yung pinaka-pure na vinegar? Yung 10 ml of vinegar solution times 100. At ano ngayon yung ating magiging answer? Ang magiging answer is answer over 10 times 100 is equal to 3.39. 3.39% acetic acid. So, by this equation, masasabi natin, or by this solution, masasabi natin na, tama, nag-follow yung dato puti sa standards na sinet ng FDA. Pero that is just one of the procedures or one of the solution. Now, let's go to another solution para masabi nga natin na tama talaga yung computation natin. So, one of the solutions that we are going to utilize is using stoichiometry. So, yun naman, nandito naman tayo sa stoichiometry. Okay. So, in this equation, kailangan natin ng molarity. So, kailangan natin ng molarity ng ating NaOH, di ba? So, ito yung pinakatama nating gawin. Kasi, bago kasi natin malaman, di ba, kailangan mo natin ng molarity ng standard. So, dito, sa second procedure natin, kailangan natin ng molarity ng ating NaOH. Okay? So, alam na natin yung molarity ng NaOH, which is 0.49 molar. So, yung 0.49 molar na to is i-convert natin siya papunta sa mole ng CH3COOH or papunta sa mole ng acetic acid. I-convert natin siya papunta sa mole ng acetic acid. Pagkatapos, i-convert natin yung mole ng acetic acid sa grams ng acetic acid. Tapos, yon, makakuha na natin. Paano ba? So, papunta siya sa mole ng NaOH, papunta siya sa grams ng acetic acid. So, katulad ng sinabi natin kanina, i-utilize natin yung stoichiometry map. So, ang kailangan natin is mole of NaOH muna, papunta sa mole ng acetic acid, papunta siya sa mole ng acetic acid. Sa grams ng acetic acid. Sorry. Okay. So, anong i-utilize natin dito? We have the molar ratio. I-utilize natin dito is the molecular weight. So, molar ratio ay makukuha natin sa ating balance equation. So, ito na yung ating balance equation. We have an acetic acid and NaOH, i-utilize or pakakaproduce siya nito. Okay, there is a 1:1 molar ratio. Okay, so let's now go to our conversion. So, 0.49 mole of NaOH. Nakuha to sa molarity ng NaOH natin kanina over 1 liter. So, that is equal to the molarity. 'Di ba? Ang given natin, meron tayong 0.49 molar ng NaOH. At alam naman natin na 0.49 molar is equal also to 0.49 mole over liter. Mole over liter. Kaya, translate ko lang siya dito para mapalabas natin yung mole. Tapos, i-convert natin siya sa mole ng acetic acid using our molar ratio. So, we have 1 mole of acetic acid. Let's say this is acetic acid. And there is a 1 mole of we have 1 mole of NaOH. Okay, I'm sorry guys. And there is a 1 mole of acetic acid here. Para ma-cancel natin siya. Okay, ika-cancel natin. Now, let's go to utilizing the molar weight papunta sa grams ng ating acetic acid. Ano yung ating 1 mole ng acetic acid ay meron siyang 60.052 grams. 60.052 grams. So, cancel. Okay, final na ba? Makukuha na ba natin yung ating grams ng acetic acid? Hindi pa. Kasi, pag nag-solve na tayo ng ganito, ang magiging answer natin is grams per liter. So, kailangan nating makuha si liter dito. Paano natin makukuha si liter? We can use, pakukuha natin siya by utilizing the total volume consumed of NaOH. So, the total volume consumed of NaOH here is 2.3 ml. So, i-convert natin siya sa liter times 0.0023 liter. So, ika-cancel natin, okay na. Grams na ang makukuha natin. So, sige nga, ano kaya magiging answer natin? 0.49 over 1. Let's say 1. So, 1:1, yung molar ratio. Then, we have 60.052 over 1 times 0.0023. So, we will get a answer of 0.0677 grams of acetic acid. Grams of acetic acid. Now, since meron na tayong grams ng acetic acid at ang ating formula para sa percent composition is mass of solute over volume of the solution, pwede na natin siyang isolve. Di ba? So, paano? So, percent composition is equal to the mass of solute over the volume of solution. So, ang mass ng solute natin is 0.0 times 100. Okay, 0.0677 grams of acetic acid. Ano naman ang volume na gagamitin natin? Guys, Okay, ang volume na gagamitin natin dito is hindi na yung 10 ml. Okay? So, ang volume na gagamitin natin dito, since ginawa na natin yung experiment, ang volume na gagamitin natin dito is yung volume ng vinegar na ginamit mismo natin dun sa experiment. At ano yon? Di ba sinabi doon, after nating i-dilute yung ating vinegar, kumuha tayo ng 20 ml or nag-aliquot tayo ng 20 ml. So, ibig sabihin, yung 20 ml yung gagamitin natin. Tama ba? Parang ganon. Okay. So, pagkatapos ng 20 ml, this is a vinegar plus water. Tapos, nag-add ulit tayo ng 30 ml ng water. Pero, ang kailangan nating gamitin dito is yung solution na meron talagang vinegar na. So, ito yung gagamitin natin at i-disregard na natin to. Pero, since ang ating formula is mass of solute over volume of the solution, yes, it is a solution, pero may halo na siyang tubig. Diluted na siya. Ang kailangan natin is yung vinegar lang. Pero, paano natin makukuha yung vinegar lang? Samantalang nahaluan na natin siya na tubig. Bibilangin ba natin yung mga vinegar na yon? Hindi. Gagamitin natin tinatawag na dilution factor. Hindi ko alam kung paano mo siya i-pronounce. Dilution factor. Okay, dilution factor is equal to the volume final over the volume initial. Bago natin siya i-dilute, ang volume final natin is 10. Ang volume initial natin, bago natin siya i-dilute, di ba? Nagkumuha muna tayo ng 10 ml, di ba? So, ang volume initial natin is 10 ml. Nakakasunod, volume final is pagkatapos natin siyang i-dilute, Pagkatapos natin siyang i-dilute sa 100 ml na volumetric flask, at ang volume initial natin is kung ilan yung volume ng vinegar talaga ang kinuha natin. So we have 10. So ang ating dilution factor is 10 by the factor of 10. So ibig sabihin, i-divide natin yung 20 ml na vinegar plus water solution by 10 para makuha lang natin kung ilan yung vinegar dun sa ml na yon. So, ibig sabihin meron tayong 2 ml. Ibig sabihin, ang pinaka-concept niya is, in every 20 ml of vinegar and water, 2 ml doon ang vinegar. Gets? In every 10 ml or 20 ml of vinegar and water solution, 2 ml lang doon ang vinegar. So, ilalagay natin dito ang 2 ml, tapos ito times natin siya ng 100. Magiging pareho kaya yung answer natin? Let's see. Okay, so answer over 2 times 100 is equal to 3.38. 3.38% acetic acid. Pareho ba ng answer natin kanina? Hindi ko na ano. Okay, so magkapareho. 3.39, 3.38. Okay, siguro kasi ang ginamit ko lang dito is ito lang. Dapat sobrang haba kasi niyan eh. Okay. So ang last natin, 3.38 pala. Wait lang. I checked. Ito, 3.38. I checked. So, i-check nyo siya ulit. Mali lang yung pag-round off ko. So, ang answer kanina is 3.3839. So, ginawa ko siyang 3.39 pero 3.38. So, pareho lang din. Okay. So, I stand corrected. So, ang last solution natin ay ang last solution natin ay may unit na grams per 100 ml. So, kailangan natin kunin yung grams of acetic acid per 100 ml of vinegar. So, paano natin siya makukuha? We will now utilize as well the stoichiometry. So, i-utilize ulit natin siya sa stoichiometry. Ang una nating gagawin is to get the mole of acetic acid coming from the mole of the sodium hydroxide solution. So, the mole of NaOH to the mole of CH3COOH. So, ang i-utilize natin dito is the molar ratio. Okay. So, in our data, so we have 0.49 mole of NaOH over 1 liter times 1 mole of NaOH and then 1 mole of CH3COOH using our balanced chemical equation. Okay. So, hindi pa rin tayo titigil dyan. Kasi ang magiging answer ulit natin is molarity ng CH3COOH. Pero ang kailangan lang natin is ang mole ng acetic acid. Okay. So, paano natin kukunin yung liter? Kukunin natin siya by multiplying it by the volume consumed. Ang volume consumed, for example, sa trial 1 is 2.3 ml. So, it is 0.0023 liter. So, cancel. Ano makukuha natin? So, we have 0.49 over 1 times 1 times 0.0023. So, we will get 1.127 times 10 raised to negative 3 mole of acetic acid. Okay. Mole of acetic acid. So, this mole of acetic acid, can be written like this. 1.127 times 10 raised to negative 3 mole of acetic acid in every 20 ml. So, anong ginamit natin kanina, di ba? Nag-aliquot tayo ng 20 ml ng vinegar plus water. Pero, ang kailangan lang natin dito sa denominator natin is yung mismong vinegar lang. Tapos, ang ginawa natin kanina is dinivide natin yung aliquoted 20 ml ng kanyang dilution factor which is 10. Kaya, we have 2 ml here. So, there is a 1.127 times 10 raised to negative 3 mole of acetic acid in every 2 ml of vinegar. Tapos, ito times natin siya ng 100 ml. Kasi dapat maging unit natin is grams of acetic Yeah. Ang magiging unit natin is grams of acetic acid. I-times natin siya ng 100 ml kasi ang magiging unit natin is grams ng acetic acid in every 100 ml of vinegar. So, cancel, at makukuha natin ay 5.635. Mali. Ang makukuha natin is 1.1272 times 100. Makukuha natin is 56.35. 56.35 mole of acetic acid. Okay. So, hindi pa rin tayo titigil dyan. Pagkatapos natin makuha ang mole ng acetic acid na to, i-convert naman natin siya sa grams. Okay? Paano natin i-convert yung mole ng acetic acid sa gram? I-convert natin siya sa gram ng acetic acid by using our molecular weight. Okay. So, we have 56.35 mole of CH3COOH. So, 1 mole of CH3COOH is equal to 60.052 grams. So, ano kaya magiging answer natin? So, we have 60 times 60.052 over 1. So, we'll get, wait, 1, 2, times 10 raised to negative 3 over 2. Kaya pala. Okay. May raised to negative 3 pala. I'm so sorry. Over 2 times 100. So, we'll get a 0.05635 mole ng ating acetic acid. Okay. So, 0.5635. Okay? So, ang answer natin, ito times natin siya sa 60.052. Makakukuha tayo ng 3.38 grams of acetic acid in every 100 ml vinegar solution. So, compare natin. Here, yan. Here, ito. Tapos, yung kanina, which is ito. So, we get the same answers. Using the 3 methods. So, yes, it can be concluded that dato puti vinegar follow the standard of 4. So, yun yung ating mga solutions for the identification of total acid content of the vinegar. That is only for our trial 1. So, you can use the data here and trial 2 kung gusto nyo mag-solve, or kung gusto nyo, gamitin nyo na lang yung data nyo para malaman nyo kung tama ba yung solutions natin kanina na almost 3.38% lang yung acid content ng ating vinegar. So, malay nyo, yung data nyo pala, nag-ano siya ng 4% na acid content. Okay. So, ang next na ating pag-aaralan is particularly word problems involving titration. Word problems involving titration. Okay. So, in this first problem, consider the titration of acetic acid with sodium hydroxide. At 10 ml of acetic acid requires 37.55 ml of 0.223 molar NaOH. So, what is the concentration of acetic acid? So, ang pinakauna nyong dapat gawin dito when you are encountering this type of problem is to identify the molar ratio or to write the balanced equation. Since we have here an acetic acid, so that is particularly CH3COOH plus NaOH. So it will produce NaCH3COO plus H2O. So ang kanyang molar ratio is almost 1:1 lamang. Gets? So, pag 1:1, yan, ibig sabihin, pwede mong gamitin yung ating dilution equation, which is CV is equal to CV. The concentration of the acid times the volume of the acid is equal to the concentration of the base times the volume of the base. This concentration can either be in molarity, in normality, or in percentage. And this volume is dependent sa given, which can either be in ml or anything. So dito, given yung ating given ang ml ng ating acid, tapos given yung ml at ang concentration ng ating NaOH. So we have here 37.55 ml, that is the volume. The concentration is 0.223 molar. That is for the base. Ang ating hahanapin is magkabaliktad. Okay. Ang ating hahanapin is concentration of the acetic acid. So, given yung ating volume ng acetic acid, which is 10 ml, ang ating hinahanap will be the molar of acetic acid. So, ang kailangan lang natin is i-multiply natin itong dalawa, which is 37.55 times 0.223 over 10, makakakuha tayo ng 0.837365 molar acetic acid. that is for the titration word problems. Okay. So, this equation, CV is equal to CV, ay para lang sa 1:1 ratio. Pero, halimbawa, paano naman yung mga hindi 1:1 ratio? For example, in this problem, a 10 ml of sample of 0.55 molar sulfuric acid is titrated with 0.233 molar NaOH. So, what volume of NaOH is required for the titration? So, anong gagawin natin? Ang unang gagawin natin is to have the balanced chemical equation. So, the balanced chemical equation is we have here a sulfuric acid plus sodium hydroxide in order to form a sodium sulfate plus water. So, pag in-analyze mo siya, hindi pa balance yung equation natin. So, maglalagay tayo dito ng 2. Maglalagay ulit tayo dito ng 2. So, yan, na-balance na natin yung equation. So, there is a 1:2 molar ratio. So, pag nalaman na natin yung kanyang molar ratio, pwede na rin natin i-utilize yung ating CV is equal to CV. Okay? So, concentration of acid, volume of acid, concentration of base, volume of base. So, concentration of acid in our problem is we have 0.555 molar sulfuric acid. The volume is 10 ml. Ang ating concentration ng base is 0.233 molar at unknown naman yung ating volume. So, pag nakuha natin, i-divide lang natin siya. So, we have 0.555 times 10 over 0.233. Okay, so we will get a 28.82 ml. Pero, hindi pa dyan natatapos. Kasi nga, ang ating ratio kanina is 1:2. So, ita-times natin tong ating NaOH ng 2. Kasi, di ba, there is 1 mole of sulfuric acid in every 2 mole of NaOH. So, ita-times natin siya ng 2 para makuha natin ang answer na 47.64 ml NaOH. So, ang pinaka-importante lang na formula natin dito is this dilution formula. So, masosolve mo or magagamit mo siya without no worries pag 1:1 yung ratio ng ating acid base. Pero kailangan mo siyang i-times ng ratio ng acid or base pag hindi siya 1:1 yung ratio. Katulad dito, 1:2. So tinimes natin siya ng 2 kasi kinukuha natin yung ml ng NaOH. Okay? Tinimes natin siya ng 2 kasi kinukuha natin yung ml ng NaOH. So, yon. So, yun yung mga pwede nating ma-encounter na problems bukas. Katulad nito, utilization ng formula, ng ating dilution formula, as well as the standardization equations. Okay? So, hindi ko na ituturo yung ating post-lab kasi it's kind of complicated. Pero if you want to learn it, then you can just PM me. Bye!